of its capabilities, not in terms of using it, that you get this immense growth every time you add a new feature. We have things like sets are built into Speakeasy. We do set algebra. And we use the set algebra. It was originally we wanted sets in Speakeasy. Nobody knew why you would want them. Turns out we use it in Speakeasy now to be sure we have documents for every linkule. We look at the linkule list, we look at the help list, and do set operations. And with this, with the keyword, you can do logical ands and ors on the keywords and find specific documents. Those are written in Speakeasy subroutines. Does anybody have any questions? I've been doing this blind so far.
Can you give an example of how you use combinations of words to give the syntax?
That's a test of me, not of it. Gary, can you think of a good one? I mean, oh, I can use a roll on the matrix there that I have. Okay, I can roll it, which is a word in the language. Okay, where's X? Okay, there's X printed. Let me get to the top of the screen. What I'm going to do is to move it one column by doing a roll operation, and then I'll transpose it. So I can say transpose roll roll left. So what that does is to roll it left one unit. It'll come up on the screen, so you'll see it there. What it did was it rolled it one unit and then transposed it. Yes. If you think that this is Fortran and understand Fortran, this is using Fortran notation. So this might be an operation that you would like, and you can save it in a funny way. You can write a Speakeasy program, which you could call a Speakeasy subroutine called transroll, which does this operation. If you use it very, very frequently, you could go to a programmer if you didn't know how to program and ask him to write this, put it in the library, and that would become a part of the language. So it's that sort of thing that makes it really powerful. And it's, for those of you who know APL, Speakeasy has this common thing. You have to figure out how to combine the operations to do what you want to do and avoid looping. And typically, if you have a program that it has many loops in it, if it has a double loop, you know there's something wrong. There is some way to write it so you don't have it. Even if you have one major loop, you can typically, unless it's a case type loop, you can typically find the operations in Speakeasy. And that's a skill. One of my coworkers, Steve Piper, is extremely good at this. He has a concert society mailing list, which is immense. And he does all these marvelous things of sorting them by zip codes and last names. He does it in Speakeasy with simple programs. But you have to sort of stare at it a while to figure out how to do it. I think now I just want to do one thing, which is show you the dramatic effect of putting Speakeasy on the vector, which is something which is a little frightening, because when I first started this thing, my view of IBM sort of atrophied, I think, when I moved from Argonne into the private world. In my picture of computers, IBM had things with numbers, 3033s, 3038s, and they kept happening with new numbers. And suddenly we were presented with the fact that they wanted us to be on a 3090, which was just another number with a vector, and I didn't know what that was exactly. And over the past few months, I've discovered that, in fact, IBM is in some sense not second to anybody in terms of power with supercomputers. The IBM 3090 with several vectors running in parallel, which is a capability that is available imminently, is as good as any other supercomputer in the world. The interesting thing from the user viewpoint of Speakeasy is that you can go on to Speakeasy on this machine and run exactly the same way you run on that machine that you ran 10 years ago on TSO. The user doesn't see anything different, except for a few things. The very first line of Speakeasy, you can specify how big a workspace you want. And our limits on, originally, back in the old days, was 10K. You type in 10. The micro version, which we have, which we don't like because our users complain that 64 is the biggest they can go. 64K was immense when we first started. The default on any machine now is 100K. On this machine, let's see, on this machine I can get 2000K. I tried it the other day. On the vector you can get 2 gigabytes. And one of our tests, and it's hard to get impressed with computers